The first thing we need to do to find electron configurations is to find the number of electrons for the element. So we can find this on the periodic table, and we're going to look at the number above the element symbol, which is called the atomic number. That'll tell us the number of protons, but it also tells us the number of electrons. And we can use that number as we try to find the electron configuration for whatever element we're interested in. So we'll move helium over to group 2 since it fits better there for electron configurations. We have our periodic table, and we just need to memorize that every element in group 1 ends in S1, group 2 ends in S2. We'll go over to the P block. Those elements in group 3, they end in the P1, and then P2 all the way up to P6. Going back to the transition metals, we start with D1 and go all the way to D10. For boron, we'll look first at row or period 1 on the periodic table. And we can see that the hydrogen has atomic number 1. It is in row 1, so we're going to write 1 down. That's the period. It's also the energy level for the orbital that we're talking about. Then we'll go to number 2, which ends in S2. So we're going to call the first part 1s2, and then we're done with period 1. We'll go to period 2, and we see that lithium, atomic number 3, that ends in S1. Next, beryllium, that ends in S2, and those are all of the S's in that second period, or energy level. So we're going to put 2s, and since there are 2 electrons there, 2. Now we're going over to the P block, and we're at boron, which is the element we're writing the configuration for, and we can see that boron ends in P1. Now we're still in the second period, so it's going to be a 2p, and boron ends in 1. So that's it. That's the electron configuration for boron. We'll do chlorine the same way we did boron. In row or period 1, we can see with hydrogen, we'll start atomic number 1, we have the 1s1 and 1s2 full, so we just write 1s2. We go across, and we're actually back in row or period 2, so we have lithium and beryllium, 2s2, that's full. We go over to the P block, and we have all of that full, P1 through P6, so we just need to write 2p6. We go down to row 3, we have 3s1 and 3s2, those are full, so we write 3s2. We're back over across to the P block, and we can see chlorine's there at P5, so we're almost there. So we put 3p, and since chlorine's in the P5 group, 3p5. That's the electron configuration for chlorine. We'll try one more, vanadium. So vanadium has atomic number 23, so we have 23 electrons, and we're going to go through the periodic table until we get to vanadium. So we'll start in period 1, there with hydrogen, atomic number 1, and we see the 1s1 and 1s2, those are full, so we'll write 1s2. Now we move down to the second period. We have the 2s1 and 2s2, those are full. Then we go across, we're into the 2p's, and all of the p's are full, so we'll put 2p6, down to period 3, 3s2, then we have all of the 3p's, those are full as well, so 3p6. We're down to period 4, and we're getting close to those 23 electrons that we have for vanadium. So in period 4, we have 4s1 and 4s2. Those are full, so we'll write 4s2. And then we're into that D block there, and if we go over 1, 2, 3, that's where vanadium is, so we would expect that we would have 4d3. However, this is the one exception that you need to be aware of if you're using this method. When we get to the D block, we always take one away from the period number. So instead of 4d3, we would have 3d3 as the electron configuration for vanadium. So at this point, it really becomes just a matter of practicing them. Do them yourself, struggle with them, and then look at the answer. And go back and do this until you can get them right every time. The pattern's pretty much the same for all the elements. You just continually add electrons on. This is Dr. B, and thanks for watching.